This video would give a brief introduction to what values are, what expressions are, and what statements are in JavaScript. This is an excerpt from the second part of a course called JavaScript for Visual Learners, which I'm putting together at the moment and which will be made available in the next month or so. Hopefully you would find this very visual introduction to expressions and statements useful. One thing that I always like to do is to break problems down into their components. For example, if we want to think about a program, what can we say its building blocks are? You can imagine that if we understand what the building blocks are, we can understand programming much more easily. At the most basic level, we can think of programs doing the following. One thing that they can do is that they can create values which would either be used immediately or would be stored for later retrieval. In part 1 of the course, we spend a fair bit of time discussing what values are. As a reminder, they can be primitives, things such as numbers or strings or booleans or undefined or null, or they can be objects, things such as functions. So every time we define a value, we can either use it right away, for example in some kind of a calculation, or we can store it in memory for later use. Of course, the moment we store a value in memory, it becomes a variable, and we have already discussed variables. And this is pretty much as far as we got in the first part of the course. We discussed the various types of values. Well, of course, you can imagine that to have a working program doing something useful, we have to do more than that. So we need more things than values to make programs work. This brings us to the next big item of what makes programs useful, which is expressions. You can simply think of expressions as pieces of code that result in a value. For example, every time you add two numbers in a program, this would be an example of an expression, and the result in this case would be the resultant value. Remember, expressions always result in values. This is their definition. Of course, one thing that we really want to have in a program is the ability to generate new values. This is what allows us to make new things. Let us go through a very simple visual example of an expression. In this case, we have two values. One of them is stored in a variable and the other one is temporary, a red ball and a blue ball. And then we would have an expression, which in this case is represented by an addition operator. We will talk about what operators are in just a little bit. The main point would be that the addition operator in this case can accept the two values as inputs and then can generate an output by adding up the two numbers. The output would in fact be the value of the expression. So far we've talked about values, we've talked about variables, and we've talked about expressions where we can take values and create new values. We can have inputs and generate outputs. But there is something else which is very useful to have in a program, which is the ability to take individual steps, complete individual actions. And this is indeed what statements are. You can, for example, take the value that we just generated in our expression and then assign it to a variable. Or you can then take this variable and do something else to it. For example, show it in the console. Both of these steps would be examples of statements, which are individual actions. If you think about it, we did a couple of individual steps to get to where we ended up with, showing something in the console. Both of these things were statements. How about we go through a very simple code example to get a good feeling for what is the difference between an expression and a statement. For example, what if we have the following code? Let answer equals to 6 times 7, semicolon. Let in this case would be a keyword. Answer would be the name of a variable or an identifier. The equal sign would be an assignment operator. 6 would be actually a primary expression. The multiplication sign would be a multiply operator. And 7 would be another primary expression. 6 times 7 would be a binary expression which would result in a value. The value, of course, would be the number 42. The semicolon at the end indicates that the line of code is a statement. So in this simple line of code we have a couple of primary expressions, the numbers 6 and 7, a binary expression, 6 times 7. The resultant value is then assigned to a variable, making the whole line of code a declaration statement. The declaration statement is a single action. We take a couple of values, 6 and 7, we multiply them, and then we assign the answer to the variable, which in this case is answer. The semicolon at the end of this line is significant here. We use semicolons in JavaScript to indicate the ends of individual statements, the ends of individual actions. So let us use one of our models to visualize the code. Let answer, in this case, would generate a variable in which we will be assigning a value. The value itself would be made up of the number 6, a primary expression, which would be one of the inputs into a multiply operator. The number 7 would be the other input in our multiply operator. And then we would have a final result of 42. And it would be the number 42 which would then be assigned as the value in our answer variable. The multiplication of the two numbers and the assignment of the value to the variable would represent a single statement, a single action.